Now at reaction of esters with Grignard reagents, and what we're seeing here is the addition of two equivalents of Grignard reagent to an ester, and we end up getting a tertiary alcohol as a product. If you think way back to the reaction of, let's see, this one here, organocopper lithium reagents, you'll remember that we used one equivalent of a Grignard-like reagent, which was an organocopper lithium reagent to form a ketone. And the comment was made back here that if we used a Grignard reagent, we'd end up with appreciable amounts of attack on the ketone as well to produce a tertiary alcohol. Well, we can take advantage of that and just go ahead and use a Grignard reagent on an ester, and that will give us a tertiary alcohol, and there's no fear of side products or anything else because that's what we're going to be aiming for. But to do that, we're going to need two equivalents of actual Grignard reagent to achieve that. Now, in part, it sort of follows the negative mechanism, at least for a little while, and then there's a little bit of a twist at the end because we end up attacking the formed ketone with a Grignard reagent, another equivalent of Grignard reagent. So let's take a look at the mechanism. And you'll see the negative portion of the mechanism firstly. So here's our Grignard reagent, comes in to attack. And remember, to get the Grignard reagent, we look at the C to which the Mg is attached, and that's where the negative charge goes. Alright, so now we've got this. There's a new bond forming here, and then we've got our Grignard reagent. Now the negative is going to come down, kick out the leaving group, and we get a ketone, initially at least, after the attack of the first equivalent of Grignard reagent. But since we've got two equivalents available, the second equivalent will come in and attack the C double bond O. And then we've got our O negative. So now we've got the H plus that can be added, and I'm going to add the H plus to both negative species here, both the negative species from the leaving group and the negative species from the attack of the second equivalent of Grignard reagent, and that's how we'll end up with our two products. Alright, and remember that when we're adding H plus in the second step, we're adding enough so that we can make anything negative into a neutral compound, or just to make the solution into a neutral or acidic type solution.